Hello students, we will solve class 9 maths question paper today. This is the paper. And this is common annual school examination year 23 to 24. It's available in Hindi and English both. We'll solve English first and in the next video we'll solve in Hindi the same paper. So if you are watching, mm, I mean if it's not been so many days from the day I am recording this video, then please, you may not find the Hindi version yet, but it's already been months. Then you please check the playlist. You will definitely find the same video covering the Hindi part of the question paper. As you can see, this paper has total 5 sections: A, B, C, D, E. D carries the maximum marks, so each question carries 5 marks each. So my recommendation is always start with section D. Section A checks your basics, that's MCQ. When you attempt section D, which is advanced problems, you can say. So advanced problems are always based on the basic concepts. So basically, while you are doing section D, you will be brushing up your basic concepts for section A. Section A will become automatically easy for you to cover and you will save time later. So, and second benefit of going with section D first is you will be securing 20 marks in just few minutes. Okay, this is section D. The first question is, in a parallelogram ABCD, 2 points P and Q are taken on the diagonal BD. BD is the diagonal. Diagonal is what connects the opposite vertices of a shape. So B and D, A and C are the opposite vertices. Vertices. If it's plural, it's vertices. If it's singular, it's vertex. Such that DP is equal to BQ. These smaller parts BQ and PD, these small line segments are equal. Prove APD, the top smaller triangle is congruent to CBQ, lower congruent triangle. Let's draw the same shape here. This is ABCD, BD. They said it's a diagonal, so let's join them. They have also joined, okay, straight lines like this. This is P, this is Q. Join AP also and CQ also. The triangles that we need to prove congruent are these. Okay, this is what we need to prove. A triangle APD is congruent to triangle BQC. Next, just focus on the highlighted triangle, which is blue in color, and AD is equal to BC. What are we doing? We are trying to prove the triangles as congruent. Congruent means we need to satisfy or fill these 3 boxes. These 3 boxes can be filled either by side or either by angle. Side angle, side angle. So this combination, whatever the combination is in the end, that will decide the congruency concept. If we get all S's, like SSS, that will be triple S congruency. Using triple S concepts, we will prove the triangles are congruent. When we say congruent, this is the sign. Congruent means the shape are equal in terms of corresponding sides and corresponding angles. Why are why am I using the word corresponding? Corresponding means overlapping. If you cut a triangle in a piece of paper, let's say this is how your cut looks like, and you cut another shape of the same shape triangle, but it's a little bit bigger than the other shape. And if you try to overlap like this, give it a name, ABC, A dash, B dash, C dash. Now if you overlap this ABC onto this A dash, B dash, C dash, it won't match because it's smaller. So ABC will end up somewhere here. So we will say the corresponding sides are not overlapping. This is why they are not equal. Okay. Now this is all the combinations we will look for as we solve problems. You will understand more because it's all theoretical. Theory doesn't make sense unless you solve problems. So let's solve problems. You will definitely get the concept. So if I have written, let's say AD is equal to BC, AD is equal to BC. The reason being it's a parallelogram. They said in the question it's a parallelogram, the outer shape. And in parallelogram, we know opposite sides are equal. So write like this, opposite sides are equal. First, what is AD? AD is a side. So right side, one S, one block is done. Next, they also said BQ, this is smaller line segments are also equal. So BQ is equal to PD. I'm not saying it, the question said it here. So when question says something and I'm using it, I will say given in the problem, in the question. What is BQ and PD? It's also a line segment. Line segment means it's a side, kind of a triangle. The blue triangle, it's a side. Now two boxes are filled with SS. Next box, let's see. Now focus on BD as a transversal. BD is not just a triangle. I'm just extending the line BD and it looks like a line because it has both arrowheads on both sides. If BD is a transversal, this is what I'm assuming. No, I'm looking at it's not an assumption. So BD is a transversal line. If there is a transversal, there should be some parallel lines in the discussion. Try to find the parallel lines here. One parallel line is BC, second line parallel line is AD. So we will say AD is parallel to BC and this is my transversal line BD. So alternate angles are here. This angle and this angle are alternate interior angle and they both red angles are inside the blue triangles that we are trying to prove congruent. This is what you need to always try. What's the point in talking about the sides and the angles that do not fall inside the triangles that we are interested in? So because I'm interested in to proving blue triangles as congruent, so you will talk only about the things that make sense inside the blue triangles. Okay, so this is the reason I specifically picked BC and AD as a parallel lines, did not AB and CD because those are also parallel. BD is also transversal for AB and CD, but they won't make sense at the moment because my triangles are not touching the A, B, and CD in any way internally. Okay, I hope you got the idea. So we got the angle as ADP is equal to CBQ. What is this angle ADP? It's an A angle. Okay, now we will say it's SAS congruency. Why SAS? This is one side, another side was this, and our angle is sandwiched between these two sides. This is why S is this, BC and AD. Last S is BQ, and PD, and this is our sandwich angles. This is why SAS, and SSA is not a congruency. If you find this combination in any triangles, the triangles may not be equal, may not be, and whenever there is a doubt, may not be, there are options, then we can't call those shapes as congruent. This is why SSA doesn't exist. Now you have proved, so you can say hence those triangles, triangle APD is congruent to triangle PQ and C. First is done. Let's check second. Prove AP is equal to CQ. Where is AP? Only this part. Let me highlight this with some other color. This part, AP is equal to QC. Okay, we just proved the same triangle because AP is one of the sides of the same triangle that we proved congruent just a moment ago. So we will write like this, since, write like this, since, or two columns and single dot just below it. It's basically inverse triangle. This is also called as since. Now, since triangle APD and triangle BQC are congruent, what can we say? All sides and angles are correspondingly equal. This is what the meaning of congruence. It means all the sides and angles are correspondingly equal, which means correspondingly they will overlap with each other. Hence, we will say CPCT. This is a shortcut. Instead of proving the congruency again and then saying that the sides AP and CQ are equal, we will use this little help. Its meaning is corresponding parts of corresponding triangles. Let me write it. Corresponding parts of corresponding triangle. Its meaning is, we just explain the corresponding meaning. AB should overlap with, must overlap with A dash B dash. It's not like AB is overlapping with side A dash and C dash and we can say the triangles are equal. No, we can't say because it has to be a corresponding. AB is on the left side of a shape. This A dash B dash should also be on the, or basically the equal side of AB in other shape has to be on the left hand side only. This is how the overlapping works. So corresponding parts. What is the meaning of parts? All AB, BC, AC, and angle B, angle A, and angle C. All these are called as parts of a triangle, of a shape. It says corresponding parts of corresponding triangles. Yes, these triangles are corresponding. So we are using the word CPCT as, hence, uh, CPCT, we will say, what was the side? AB, AP is equal to CQ. That's it. This is the only explanation. You use the word CPCT and hence proved. Next is AQB CPD. Prove triangle AQB is congruent to CPD. Let's draw the shape again. ABCD, PD is diagonal. AQ and CP. It looks like AQ and PC are perpendicular lines, but they are not because they have not mentioned this in the problem. So always do this unless it is given. Don't go with the assumption. because if you all assume as if AQ looks like a perpendicular, so it will trick everything. It will make the problem more complicated and wrong. AQ is not perpendicular, it looks like so, but we will consider it as just a line. Okay, this is the shape AQB. Now the focus should be on AQB. That right triangle I am highlighting, red triangle, sorry. Okay, it's similar to top and bottom, the first part. Now AB. AB is equal to CD. Why? Because it's a parallelogram. And not just that, we will write like opposite sides are equal in parallelogram. One box is filled with S. Next, BQ is equal to PD. Why? It's given in the question. Second box is also filled by S. Next, let me extend BD and consider BD as transversal line, and AB is parallel to CD. So this angle, blue one, is equal to this blue. So we will write angle ABQ is equal to angle PDC. Why? It's alternate interior angle. Whenever there is a transversal line, always find for parallel lines and make find the angles that are being made using both transversal line as well as the parallel lines, and give it a name. Though there are 7 names or 7 concepts that you can go with, I'll not cover all 7 because this particular problem only needs alternate interior angle. So we have found another box which is filled by A. Because SSA as a congruency doesn't exist, this congruency doesn't make any two shapes of a triangles congruent, but the another one exists, SAS. But again, I can't make this up. It has to be SAS. What is the meaning of SAS? Two sides are sandwiching an angle in between. Let's look at the figure whether we find our angle sandwiched by the two sides or not. AB and CD are equal. So this is one side. BQ was said to be equal to PD. This is another side of the triangle. And when you look at these two sides are sandwiching our angle. Yes, it's in between. So this proves it's SAS. So we'll say SAS congruency makes triangle AQB congruent to triangle CPD. Next problem. Prove APCQ is a parallelogram. APCQ. The inside box. Fourth is prove APCQ is parallelogram. Okay, for parallelogram, I only need to prove opposite sides are equal. That's it, because in the parallelogram, this happens. So we'll give a reference of the triangles we proved congruent so far. So triangle APD, keep checking the triangles that I'm talking about. Triangle APD, the top triangle, and the bottom triangle BQC. They both are congruent. And next, triangle AQB and triangle CPD are also congruent. But why I'm repeating myself, the same concept, because I'll use a CPCT from both. CPCT says AQ is equal to PC, correct? Through CPCT, or corresponding sides will be equal, and CPCT from the second triangle gives me AP is equal to QC. And if you look at these two things, these two are opposite sides of parallelogram APCQ. And when this we have just proved, now we have proved opposite sides are equal, then we can write hence APCQ is a parallelogram. I hope you have understood first part, first problem from section D. Let's move to next part. Oh, in a parallelogram ABCD, we will draw this here. Prove ABCD. E and F are the midpoints of side A, B, and CD. E is the midpoint of AB, F is the midpoint of CD. Respectively, show that the line segments AF, and EC trisect the diagonal AB. Okay, PQ is in between. AF is here. AF and EC trisect the diagonal BD at P and Q. Okay, trisect means if BD is a line segment, then it is, so these two lines AF and EC are dividing the BD line in three equal parts, 1, 1, 1 each. This is the meaning of trisect, means dividing something in three equal parts. Three equal parts. Tri means three, sect means bisecting, trisecting, quad secting, like this. Okay, this time let me highlight first the triangle that we will be discussing about, because one of the parts of a trisecting thing, which is DP, is a part of this. Let me make it properly. One of the parts of trisecting thing is a part of this highlighted triangle. So I'll have to pick another triangle which is corresponding triangle. EQB is the corresponding triangle to DPF. I am saying corresponding triangle. I'm not saying congruent. Congruency is what we need to prove at the moment. This is the reason I have picked up corresponding triangles accordingly. Okay. So in triangle DPF and triangle EQB, we will find these boxes. Okay, first let's do write few basic things, or the common things, or the observations basically in the parallelogram. CD is equal to AB because opposite sides are equal in parallelogram. Opposite sides are equal. What does it mean? CD is equal to AB. It means F and E are also midpoints. This is also given in the problem. If F and E are the midpoints, so AB and CD are divided into equal parts. So CD can be written like DF plus FC. AB can be written like AE plus EB. But the midpoint E and F are also the midpoints, which means DF is equal to FC and AE is equal to EB, which means I can replace FC with DF, DF plus DF. Correct, because both sides are equal. So I can replace ED with AE here. So I can write AE plus AE. What does it mean? DF plus DF, twice DF. AE plus AE, twice AE. 2 cancelled because they are same on both sides of LHS and RHS. What am I left with? DF is equal to AE. What is DF and AE? Look at the figure. DF is being said, this small part is being said equal to the smaller parts. So likewise, all the small parts are equal. So instead of writing all this, again, I can use the one word that is similarly. Similarly, FC will be equal to EB and all the small parts DF will be equal to EB and FC will also be equal to AE. So all small parts are equal to each other. You can write like this: AE is equal to EB is equal to FC is equal to DF. Now this will help because if you look at the red triangle now, so the DF, I can say my DF is equal to BE. We filled one box, which is S. Next, if I extend AB like this, CD like this, which means AE, which means I'm trying to say AB is parallel line to CD, and look at BD as transversal. BD is transversal line. So let's extend BD also so that we get the clarity. Now look at this triangle here, top right. It's touching the parallel lines and made by transversal line BD. And now this angle. It's touching the parallel line AB and made by transversal line BD. And what are these angles look like? It's alternate interior angle. So angle PDF is equal to angle QBE. I hope you have found these angles in the image. So these are called alternate interior angles. So we have found another A box. 2 boxes filled, SA. And let's look at the other boxes. We'll have to keep our focus inside these two triangles. And okay, it's going to be a very long route, so focus on my words. I'll keep explaining you slowly. Okay, it's just about tracing step by step. Okay, now focus on AF and EC. I'm saying AF is parallel to EC. Look at these two lines are as parallel. Okay, now CD is a transversal. CD is passing through them like this. correct. It's a parallel lines being cut by a transversal line, which means this angle, I'll write it here, angle DFP is equal to this angle, corresponding angles. This is why this is called as corresponding. So FCQ. I hope you have found these angles and the meaningful sense in the corresponding also. If you do not know corresponding, please read about the corresponding angles. Then it will make sense why I'm saying this as corresponding equal. But you may say this outside blue angle is not a part of the red angle, but we are connecting the dots and we will mm, build a relationship between this outside blue triangle and the angle which is soon going to be inside this red triangle. What I just said, it will make more sense if I'll show you. I hope up to this part everything is clear. Let's move on to CD. I'm saying look at CD and AB as parallel lines. If you have found the parallel lines, let me highlight the sides with some other colors so it's easy to find. This is D, this is A, this is B, this is C, F, E, P, and Q. Okay, now find AB, and CD, the sides of a parallelogram. They are parallel, and the transversal I need is CE now. I'm saying CE is a transversal. I hope you have found it. Now the same blue angle FCQ, okay? FCQ is equal to this angle QEB. QEB. How they are equal? Alternate interior angle. Alternate interior angles. Now this is how I'll write all three angles as equal. Angle DFP, follow my voice and you visualize these angles in the image. Angle DFP was proved to be equal to angle FCQ. Later we proved FCQ equal to QEB, which means in the end we can write DFP is equal to angle QEB. Both angles are inside our highlighted triangles, red triangles. We have found another A, so it's AAS congruency. So you will write using AAS congruency. You have proved triangle PDF is congruent to QEB. But we have to prove the trisecting thing instead of congruency. Now at least we have proved the congruency, which means DP is equal to QB through CPCT, congruent parts of congruent triangle. Now see these two parts. These two parts are parts of the three parts that we are trying to prove equal. Now we just need PQ. PQ is missing. At least two parts of the line BD have been proved equal. Should I draw another shape or not? Okay, I hope you will follow through, and if I ask you to follow this green triangle and the purple. This purple. Why did I choose this? Because PQ will be common in both the triangles, and since they are opposite, correspondingly opposite triangles, as soon as the moment I use the word triangle, your thought should immediately go to correspond, proving them congruent. Okay. Now I am getting PQ. PQ is what missing here. PQ. So these two triangles. Now in triangle DQC, DQC and triangle APB, APB, we will say CD is equal to AB. Why? Opposite sides of parallelogram. One S is done. Next is find AB. I'm saying AB is parallel to CD. And think, should I? BC. I should pick BD. Sorry. BD as transversal line. Okay. Focus on the purple and the green triangle and focus on the BD as a transversal line, and then angle DBA, angle DBA is equal to angle BDC. How? Alternate interior angle. You have found A also. Two boxes are filled. Third one. So this side is done. This angle is done. I consider this as equal. This and this are equal. Okay. Let's say this is going to be a again long route. Focus on, but later we proved, no, we did not. Okay, now focus on AF. I'm saying it's parallel to EC. So focus on the parallel lines, these two parallel lines. AF and EC are equal. Then I'm saying CD is a transversal. So angle DFP is equal to angle FCQ, corresponding angles. Hmm. Now on the same parallel lines, consider CF now as transversal line, which makes, so what we have just proved is this small part, sorry, this angle is correspondingly equal to this angle, which we proved earlier also. Now we will say this FCQ angle is equal to angle BEQ. Correct. Angle FCQ is equal to angle BEQ. How? Alternate again. And then we will say QEB is QEB is this angle. This angle is equal to this angle. PAE, angle PAE. How? This time it's not alternate interior angle, it's corresponding angles, correct? So I can write like these three angles are equal to each other. So we will focus on FCQ. Hmm. So FCQ was proved to be equal to angle QEB. Here is the proof. Next, we proved angle QEB is equal to PAE. We have proved it. Here is the proof. So, which means this proves angle FCQ is equal to angle PAE. FCQ. FCQ. Let me highlight this with yellow color. This yellow we have just proved to be equal to PAE. This yellow. And now yellow is inside the green triangle. This yellow is inside a purple triangle, the triangles that we were interested in. Now we have found our last box, which is again filled by A. So using AAS, you can say angle A, sorry, through AAS congruency, you proved triangles. Green one is congruent to triangle purple. But what did it prove? We were not interested in proving the triangles as congruent, but we wanted to prove the trisecting thing. Okay, now we will say through CPCT, using CPCT, we will say corresponding sides are equal. Corresponding sides are PB is equal to DQ. Now here is the trick, not trick, but try to write PB in the terms of small parts. PB can be written like PQ plus QB. DQ can be written like DP plus PQ, and we proved QB is from the earlier part. This is that part. QB was said to be equal to PD. Okay, so I can write this thing as PQ plus QB. DP is equal to QB, so I can write like QB plus PQ. QB and QB appearing both sides, so we can cancel it. In the end, we are left with PQ is equal to PQ. But what is PQ? What just happened? We just proved this is small part, middle part is also equal to itself. It's not just equal to the other parts of the line BD, but it's also equal to itself. So basically, all three small parts means PD is equal to PQ and PQ is equal to BQ. So all three parts are equal to each other, and that means BD is trisecting. I hope it makes sense. Hello Chandrakala. I do not watch, I do not monitor uh, chat section because I don't get the pings or alerts on my screen. I have no idea how to correct this behavior. It's technical bit. So I'll what I can do else is I'll try to switch between two windows regularly. It's a matter of habit. And thank you for joining. Let me write you a message here. Sorry, I missed you. Couldn't check. Message on time. Let's solve the next part below. Okay, this question number 33 will check your algebraic knowledge, but it's very straightforward type of a question. X is given as 3 plus root 5 divided by 2. 3 plus root 5 divided by 2 is the value of x. And now they are saying first prove x square plus reciprocal of x square. It's x is basically this. So we need to first find the square of it. X square will look like this is the value of x and this is x square. So you will do a whole square of this thing. And next you will find reciprocal of the same thing. So basically this part will become a denominator. 3 plus root 5 divided by 2 whole square. Later we will join these two, add these two to find this. I hope the flow is clear. Now it's just a matter of expanding something. So let's expand first this part. Okay. Now this is a whole square, numerator square and the denominator square, which means I can give squares separately to the numerator and separately to the denominator like this. This is also true. This is one of the properties of squares powers. Okay, but how did it help? So this helps me in a way to think about identities because the numerator looks like a plus b whole square and the denominator is just a numbers square, so that we can get rid of or simplify it as 4. Now why did I write the numerator as a plus b? Because I need you to uh, imagine these numbers, because 3 is visually it looks like 3, it's a different thing, and root 5 appears visually different than 3. To make it simple, let's call 3 as apple, but root 5 doesn't look like 3, so I'll have to give different fruit name to root 5. Let's call it banana. So apple plus banana is written banana plus apple whole square. This is why I can say it as, this is why I represented these two fruits with different letters a plus b, which is the identity a plus b whole square, which means it's a square plus b square plus 2ab divided by 4. What is my a? A is 3 square. What is my b? It's root 5 square plus 2ab. My a is 3, b is my root 5 divided by 4. What is 3 square? It's 9. Root 5. When root 5 is multiplied by root 5, what happens? It means this root can be written like a power of half. Multiply by this 5 has a power of half, because root is a power of half, is a power with half. Now bases are same, 5 and 5 are same. When bases are same, operation is multiplication, then powers are added. Half plus half is equal to 1, which means 5 with power 1, which means 5. So in short, square of root 5 is just 5, like this. Now it's a multiplication. 2 and 3 are both apples, not in a direct way, but both are whole numbers. So we can multiply 2 and 3 directly and get 6 root 5. Root 5 is a root number that can't be multiplied with a whole number. Root 5 can be multiplied with another root divided by 4 is equal to, now let's simplify this, 9 plus 5 is 14 plus 6 under root 5 divided by 4. 14 and 6 can give me 2 as common in the bracket, 7 left and 3 left, like this. So I've taken out 2 common from this 14 and this 6. 2 has been taken out common. Now 4 is just 4 in the denominator. Numerator 2, denominator 4, like this will be cancelled. So I'm left with 4 plus 3 root 5 divided by 2. This is a point where I'll have to stop because this can't be simplified further. And what is this? This is x square. But what are we trying to solve? X square plus x, reciprocal of it. Now once we have found x square, reciprocal of x square is just reversing the order of numerator and the denominator. This is what reciprocal does. It reverses numerator and denominator. So if 2 was the denominator earlier, it will become a numerator, and 7 plus 3 root 5 will become a denominator. It has reversed everything. Basically, this was written like 7 plus root, like this. So instead of writing like this, I just took the whole thing up in the reverse manner. I hope it is clear. Mm, Okay, once we have found our x square plus 1 by x square, now we just need to add these two things. This is my x square, and reciprocal of x square is this. This is what we need to find. Now we will solve. How do we solve like numerator and denominator problems over addition? Let's say you have numerator 1, denominator 1, then you have numerator 2, denominator 2 with plus operation in between. We do cross multiplication like this. Cross multiplication. You will look at the cross values, crossing, and you will multiply by following the plus in between. What does it mean? It means like this. I'll first multiply this 7 plus 3 root 5 with top 7 plus 3 root 5. Done. Plus is in between. I'll put a plus sign. Then I'll multiply this 2 with this 2. I said multiply because this is what's the meaning of cross multiply. Okay. Now be focused on there is a multiplication, and this plus is coming from this operation. This is the plus. Divided by, I have to multiply the denominator with another denominator. So 2 is being multiplied with 3 root 5. Now if you look at this value and this value, it's a square. Same thing. So I can write it like whole square. Plus 2 multiplied by 2 is 4. Divided by 2 is outside as a multiplier. Let's send it inside. So it will be distributed. 2 will interact with 7 first. 2 will interact with 3 first. So 2 7s are 14 plus 2 3s are 6. Whole value will always interact with whole value, not the root value. Root value will say, I'll stay as it is. You can multiply yourself with your look like, which is another whole number. Now keep simplifying. This is the only thing we have to do. Keep simplifying. This is still not simplified. Why? Because I still see a bracket, and this is a different value. This is a different value, which makes me look like a plus b whole square plus 4, 14 plus 6 root 5. And identity. a plus b whole square is equal to a square plus b square plus 2ab. This is equal to, now let's just replace everything with the number. A is 7 square plus b is 3 root 5 square plus 2ab. A is 7, b is 3 root 5 plus 4 is coming from the operation, whole divided by 14 plus 6 root 5. 7 square is 49 plus, this thing can be written like 3 square multiply by root 5 square, because I have just distributed the powers, because 3 root 5 is written in the form of a multiplier. 3 is multiplying root 5. This is 2 7 ja 14, 14 3 ja 14 3 ja is 42 root 5 plus 4 whole divided by 14 6 root 5. Let's simplify. 49 plus 3 square is 9 multiplied by 5 square. Root 5 square is just 5 plus 42 root 5 plus 4 divided by 14 plus 6 root 5. Let's simplify. This and this can be added. 49 plus 45 is 94. 94 plus 4. This is 94 plus this makes it 98, and then plus, I'm not adding 42 root 5 because they both can't be added. This is a whole number. This is irrational number. A rational number. Okay. Uh, as the denominator, I have 6 root 5. Now, see it closely and check if you can take out anything common. Common is 2. So if I take 2 common from 98, then 21 root 5. Okay, that's it. This is the simplified version, but why do I get a sense something went wrong somewhere? Some calculation. 3 root 5. 7 plus 3 root 5. So it was 7 plus 3 root 5, 2 multiplied. No, it's alright. Everything is correct. Yes, this is the step where we can stop, and you can drop your message in the comment box when you would like to connect with me live so that I can clear your doubts. Otherwise, I will come live tomorrow at some time. Time is not fixed. Hey Chandrakala, thank you so much again for joining. Let's connect tomorrow. Thank you.